General relativity paints a mathematically elegant picture of the universe, where spacetime itself can bend and fold. Yet, translating those equations into the engineering required to cross deep space has consistently hit a physical wall. For decades, the theoretical standard for faster-than-light travel was the Alcubierre metric. The premise relies on contracting the space immediately in front of a vessel while simultaneously expanding the space behind it, allowing the ship to ride a localized wave. This animation illustrates the fatal flaw in that model. To forcefully expand space behind the ship, the mathematics dictate a strict requirement for exonic negative energy, a substance with negative mass that does not exist in the observable universe. Even if we could synthesize negative energy, the sheer volume required is staggering. To move a small passenger vessel, you would need to harvest an amount of negative mass equivalent to the entire planet of Jupiter. Traditional general relativity warp drives function perfectly on a chalkboard, but they represent a physical dead end. Proceeding further requires a total shift in our theoretical approach. In 2026, independent researcher Nasanjargal published a framework that entirely bypasses the negative mass problem. The solution required stepping outside standard general relativity and operating within a broader theoretical framework known as Einstein-Cartan-Shayama-Kibble, or ECSK gravity. Standard relativity models gravity purely as the curvature of spacetime. ECSK gravity adds a critical new variable, space-time torsion, allowing the fabric of space to twist in response to angular momentum. To interact with this twisting effect, the Nasanjargal model proposes the use of high-frequency gravitational resonators, or HFGRs. An HFGR is a localized mechanical device designed to generate extreme concentrated spin density. By operating under ECSK dynamics, we can induce repulsive geometric effects using entirely positive energy. This strictly obeys the weak energy condition, the physical law stating that energy density must be non-negative. This specific framework shifts superluminal transit from the realm of impossible exotic matter to the realm of achievable metric engineering. To understand how this drive is built, we have to look at its raw geometric foundation, the architectural blueprint of the warp bubble itself. This diagram displays the ADM decomposition of the Nasanjargal line element, slicing spacetime into manageable layers. Notice the highlighted shift vector term, beta x. It dictates the coordinate velocity, defining exactly how fast the ship's space pocket moves relative to the outside universe. That coordinate velocity is directly modulated by a variable called fractal depth. Think of fractal depth as the intensity gauge of the localized space distortion. To map the outer wall of this distortion, we apply the shape function. This graph charts a precise hyperbolic tangent curve, or tan, determining how the interior of the bubble transitions to normal space. The hyperbolic tangent operator is mathematically vital here because it guarantees a smooth S-shaped curve between two distinct values. It ensures strict metric continuity. As you move from the intense fractal depth inside the bubble out into the zero-depth vacuum of deep space, the transition is gradual and mathematically defined at every point. Without this specific smoothing operator, the equation generates an infinitely sharp drop-off between moving and stationary space, a geometric cliff that physical matter cannot cross. Implementing this exact shape function is the only mathematical method to construct a stable, continuous boundary, holding the warp interior completely intact. Having mapped the shape of the bubble, we must examine the physical engine required to actually inflate it. This split screen represents the spin-torsion Lagrangian, the drive's core operating system. On the left is the vacuum torsion field, Q. On the right, the resonator spin density, S. The Lagrangian forces a coupling, dictating that resonator spin cannot exist independently of vacuum torsion. This coupling leads directly to the master equation of the Nasanjargal framework. Torsion is directly and unalterably proportional to spin. The physical implication is specific. By injecting extreme positive energy via mechanical spin, the drive directly weaves physical torsion into the fabric of spacetime. The resulting torsion forcibly twists the surrounding spacetime, pushing it outward in a massive, violent, repulsive geometric wave. Compare this against the outdated Alcubierre requirement. We are no longer relying on theoretical negative mass to push space apart. By utilizing immense rotational kinetic energy, the engine achieves the necessary repulsive curvature using strictly positive mass, entirely bypassing the weak energy condition barrier. Torsion tunneling provides the physical mechanism required to construct a positive energy engine using established warp geometry. Generating the bubble is only half the engineering problem. Surviving the physics inside of it presents an entirely different set of lethal hazards. The primary danger is the velocity gradient. If the fractal depth is not perfectly uniform across the hull, different parts of the vessel will travel at different coordinate velocities. This graph maps Nasanjargal's shearing zone. Metric A is standard space. Metric B operates at superluminal coordinate velocities. When a physical vessel straddles this gradient, the front moves significantly faster than the rear, resulting in rapid, catastrophic structural spaghettification. To prevent the ship from tearing itself apart, the design requires a localized safety mechanism, the scale coherence field. It artificially enforces a completely uniform metric state across the vessel's entire volume. By locking the internal fractal depth, it neutralizes the velocity gradient entirely, allowing the payload to cross safely. Without the coherence field flattening the local metric, the physical stress of the transition would destroy the payload. Once structural survival is guaranteed, we must address the temporal and navigational paradoxes inherent to moving faster than light. Standard physics poses a severe chronology paradox. Accelerating past light speed allows travelers to overtake their own light signals, threatening the causal flow of time. This Minkowski spacetime diagram charts the temporal solution, light cone expansion. Notice the causal cones inside the localized bubble significantly widening. By artificially widening this causal future, the vessel's trajectory remains strictly timelike, preserving causality regardless of apparent external velocity. However, this expansion creates a secondary problem. The leading edge of the bubble compresses incoming light into a dense O-tenth barrier. Traditional optical cameras are completely useless here. Incoming photons infinitely Doppler shift against the wall, rendering the ship entirely blind to the outside universe. To navigate without optics, the system employs a sensory workaround called pilot wave interferometry. Instead of catching photons, the interferometer reads the quantum potential of the universe, a hidden underlying field guiding particle behavior everywhere at once. The ship reads these baseline field fluctuations to reconstruct a real-time exterior star map. By utilizing the quantum potential instead of relying on the electromagnetic spectrum, the navigation system successfully circumvents the total optical blackout of superluminal transit. The final test of any propulsion theory is energy scaling. A drive with perfect mathematics is useless if it requires more power than a civilization can generate. Previous theoretical models failed because they required processing power and energy equivalent to the mass of gas giants. This system diagram plots the solution. By synchronizing the drive's output to match the Planck vacuum impedance at the Compton frequency, the system aligns perfectly with the intrinsic resistance of empty space. Achieving this specific impedance match generates a staggering resonant Q factor of roughly 10 to the 40th power. The Q factor is an engineering metric that measures how efficiently a resonator stores energy without losing it. This extreme resonance cascade isolates the energy, preventing almost all power bleed and pulling the mathematical demands down to an achievable scale. Thanks to that immense Q factor, the total calculated energy requirement to operate the scale drive drops to approximately 10 to the 18th joules. Generating 1 exajoule of power is still incredibly difficult, but it successfully reduces interstellar transit to a strictly industrial engineering challenge. The mechanical stack is fully defined. ECSK gravity enables the geometry. High-frequency spin creates the necessary torsion. Coherence fields ensure structural survival, and impedance matching powers the system. This marks a transition from Newtonian propulsion, which relies on reaction mass, to metric engineering, which manipulates the vacuum itself. The Nasanjargal framework provides a rigorous, fully costed blueprint for humanity's expansion into the interstellar medium.